notice, and this is the typical copyright. We continue with mathematics syllabus for CSEC 2018. As of January 2026, this syllabus has not been revised, but there are plans to change the structure of the exam from 2028 and onwards, with a few pilot projects now being conducted in a few Caribbean countries. The syllabus itself remains unchanged. The main planned change for the CSEC level mathematics exam is to split the exam into two parts. Because this is a fairly long video, I will move quickly through this introduction. Structure of the exam. As we know, there is a paper 1, there is a paper 2, and there is also a paper 3, which is a school-based assessment. And this is the marks allocated to the various papers. Schedule of videos. Those 3 have already been published since 2024 in their entirety, all 51. Please make good use of them. The others, some published in their entirety and others partially. This right now is the 17th of 26 videos, and I will explain why that became 26 from 24 that we were looking at previously. Then, of course, we have to do the rest. Please note this disclaimer down here. This schedule is just a projection and is not to be interpreted as a contract with anybody. Usefulness of section 1, even in primary schools. Other sections published, section 2 in its entirety, section 3 in its entirety, section 4, some published in their entirety, others partially. Section 5, same principle. Section 6, algebra. Section 7, recommended textbooks by CSEC itself. These over here. From those, I will recommend these that you see down here. Also, there is a very useful website with AI interactivity that deals with past CSEC math examinations questions only from paper 2. This is the URL of that website. On the next slide, I will show you what the home page for that website looks like, which is this. Again, that is the URL. A formula sheet will be provided for the math examination. So you really don't have to learn these formulae. Just make sure you know how to use them and when to use them. We are at section 8. These 4 objectives from this page, we have completed all of those. From the next page, we have completed that. And right now, we have completed this part of that objective 8, which is actually objective 7, which leaves us with these 3 parts. I was hoping to get all of those done in one video, which would have been video 15. However, this one itself runs for about 40 minutes, and this one here for about maybe 50, 60 minutes, and this other one about 50 minutes. So I cannot combine all of those in one video. I will have to separate them out into 3 different videos. So that was video 15 completed, then video 16, this part completed. We are now here at video 17. So that added 2 more videos to this section, which originally was 24. Now it would be 26. And of course, once we finish that page, we still have to go to objective 17 in this section. So these that you see here in yellow have been completed and published in their entirety, the others partially. We are now here, video 17, which is actually objective 8_8C. So notice I had to break up this objective into 3 videos. When this one is finished, it will be partially published. Projection for the rest of the videos in this section. These 4 more will be published in their entirety and the others partially. So in total from this section, 9 out of the 26 videos will be published in their entirety. But even those that are published partially, you could still learn something from those. So as I said, we are here. We are dealing with enlargement in a plane. That is the objective. And these are the details. We finish this in video 14, this in video 15, that is that. We finish this in video 16, that is that, rotation. Those 2 are not required by CSEC. So right now we are here. Enlargement in a plane. Enlargement. The glossary of the syllabus has no definition for these 2 terms, that is to say, reflection and enlargement. It does have something on rotation here, but that was in the last video. Nothing on enlargement that we are dealing with now in this video. Enlargement. Now, an enlargement is a transformation which maps a shape onto a similar shape from a center of enlargement using a scale factor of k. So let's look at this grid down here. These lines are called pattern lines, and this point here is called the center of enlargement. If we have a triangle like that, ABC, we will call that the object. And if we draw another triangle over here, A prime, B prime, C prime, like that, what we have here is an image. Now, what makes this an image? Due to enlargement. So enlargement at O with a scale factor of k. Now, the scale factor of k is a ratio of the corresponding lengths of the image to the object. For example, we could take this length here to that length there. What is the ratio of this length to that length, or that length to that length, or this side to that side? Whatever the ratio is, that is the scale factor. Or instead of the sides of the image to the object, we could take the distance of the image points to the object points. So we can take this distance here to that distance there, or that distance there to this distance there, or this distance here to that distance there. It is always the image distance or side of the image to the object distance or side of the object. That will give us the scale factor. When k is greater than +1, the image is larger. For example, if k is +2, like maybe that there, the image is larger than the object. When k is between 0 and +1, the image is smaller. For example, if k is 0.5, then this could be the object and this could be the image. The image would be smaller. On the other hand, if these k values were negative, the image will be on the opposite side of O, as we have in reflection at O. So we have 4 types of enlargements to consider. The first one is when k is greater than +1. Example, k is 2. In this case, the image is magnified and it is on the same side of O as the object. That's the first situation. The second situation is when k is between 0 and positive 1. The image is smaller than the object. For example, if k is 0.5. In this case, the image is reduced or diminished, and it is on the same side of O as the object. The third situation, when k is less than -1. The image is larger than the object. For example, if k is -2. In this case, the image is magnified, but formed on the opposite side of O. And finally, when k is between 0 and -1, the image is smaller than the object. Like if you have k is -0.5. In this case, the image is reduced or diminished, and it is formed on the opposite side of O. So we will consider these 4 cases, just one example of each. Mathematically, enlargement is a transformation that means that the image is similar to the object, not necessarily larger. Similar. It could be smaller or diminished. Enlargement transformation may also be referred to as size transformation. That is a little more accurate. It could be larger or smaller. Size transformation. But technically, we are using the term enlargement to mean either larger or smaller. Now, situation 1, when k is greater than +1. The image is larger than the object. Example, if k is 2. In this case, the image is magnified, and it is on the same side of O as the object. We saw this before. O is here, object is here, image is here. That will be when the scale factor is greater than +1. So you have an enlargement at O with a scale factor greater than +1. If we take a ruler and measure it, if we measure from here to there, we will get 58 millimeters. And then we measure from here to there, and we get 35 millimeters. Remember, it is the ratio of the image distance to the object distance. So 58 millimeters divided by 35 millimeters, that will give you 1.57. So the scale factor of this image when compared with that object is 1.57. Now here is example 1. We are still on situation 1, where k is greater than +1. Consider triangle PQR shown below. Show its image if k is equal to 2 and the center of enlargement is C. So this is the center of enlargement. That is the object. The first thing to do is to draw pattern lines from C through each vertex of the object, from C through Q, through R, through P. Not to, but through. You must project them out over on the side because K is 2. The image will be larger than the object. Secondly, use a ruler to measure, say, CP, and double that distance to find CP prime. If from here to here is 5, from here to here is 5, you double that and you get to here, which would be 10. Because remember, we are using a scale factor of 2. And obviously, you do the same thing for the other 2 pattern lines. Measure from here to here, double that to get to here, which will give us the image point for Q, which is Q prime. And then you do the same thing for C to R. measure that distance, double it. It is actually 7, you double it, you come to 14, which would give us r prime. Now, once you have those 3 image points from the object at a scale factor of 2, using straight lines, connect P prime to Q prime to R prime back to P prime to get the required image. So this is the image. This is the center of enlargement. And that is the image at K is equal to 2. Now, example 2. Consider triangle ABC shown below.